This is what we have discussed till now. HDFS component, HDFS architecture, anatomy of file read and write. Now we'll see. This is all the job we have done till now. We created a file. We store this data on data node. Now we check it. Just now we have done this all the job on our process. Now this is the map 0%, reduce 0%, map 100%, reduce 0%. This is all we have done. Right? Now we see the output as well. The output is coming this. Fine, sir. Now, what is all about and how it works, right? Now we'll see. Just take a look. The overall MapReduce word count process, right? This is what the just take a look. This is what the flow and how your job is being get executed. We have this signal, right? The MapReduce process, the overall MapReduce process and the word count process, input, splitting, mapping. We'll discuss this all the things later. Now we'll just understand the algorithm, how exactly the job is being done. This is something the input file, like we have just given that this is my pen, this is my pencil on our cluster, and we get executed and we get the output, right? The same word is being repeated how many times. Now this is what we have with the input file. We have the 3 lines, right? This is the output we have. Okay, so this is what the input deer, beer, river, car, river, deer, beer, river. This is the output we have, beer, car. Now how many times the same word is being repeated? This is given. So this is the input and the output which we have. Now between this, how actually it's done. Now we just try to understand the algorithm, what is all about the algorithm. Then we'll move to technical, how this algorithm is being converted into technical code in MapReduce. Okay. Now, first of all, I will try. We have split this input file into line by line, right? We have split this input file line by line. Then, even every line has been split into word. You can see, right, sir? And we assign a value of value 1 to every word, right? After doing this job, after performing this one operation, we go for the next. We'll make a grouping. Now we have 4 different categories: one deer, beer, river, car, right? Then all of the words is being repeated. Now we have 4 categories. We will group this all the categories. Now we can see the all words has been grouped with their own category: beer, car, deer, river. Answer. After grouping this part, we'll write, we'll convert, we'll count the data. Beer coming 2 times, car coming 3 times, beer coming 2 times, river coming twice. Right? Now I will get this all the data. I will accumulate this all the input, this all the result onto a single node, single place. Now this is what the final output we have. Right, sir? I have stopped I just stop on the chat window. We'll get back on the chat window after this, after completion of the slide. So there are a number of things we have in the slide. Just take a look, and just if you have any questions, just after coming the slides, we'll get back to you. We'll get back to the chat window. We can and from there we'll assist you on the quiz. Now you can see this is your input file splitting, mapping and all. This is what the algorithm, I hope you understand the algorithm, right? Now you can see here there are a number of steps we have, right? We have a splitting, we have mapping, shuffling, reducing, and the final result, right sir? Now what we'll do, we can see there splitting, the mapping, and the shuffling, reducing, the final result is all the steps. When we write a code in the MapReduce, there are three classes we define. When you write any MapReduce code in Java, then you define three different classes. First is mapper, second is reducer, third is the driver class. So we'll first discuss about the map class and the reduce class and the stop and the stages. So you can see here, this is what the mapper class, this is what the reducer class, right? These are the stages which we have when we write the algorithm. This all the stages comes into a MapReduce program. So this is what a complete, there's all the three stages comes under the mapper class, and this all jobs comes under the reducer class. This reducer and the final reducer, right? Now we'll see what exactly the mapping and reducing we'll discuss when we'll discuss about the coding. Now we'll see one part is called the shuffling. Shuffling is nothing where the nodes communicate to each other, right? So you can see there are different nodes where the nodes communicate to each other. Shuffling is nothing where we are creating a group of different words, right? Now we see here K1, V1, K2, V2, K, K3, V3. There are different K3, V3. Now we'll discuss K1, V1 later. Now what exactly can be the key and the value? Hope from the guys from the Java background, those who understand what exactly key value is nothing. There's a collection, and there's a topic in collection we have in which you might be discuss about the hash map and the hash tag, right? A good example based on the key value, like a phone directory. If you want to find the details of any number, right? You just open a phone directory, you write the number, and you enter, right? After giving the phone number, you enter all the details of that phone number, the person who is registered with the SIM, the number, the detail, the address, everything is in that information, right? So key is nothing, your phone number, and your value is nothing, that complete details. So your phone act is based on the key value. Your Google search engine is as well as it is made on the key value. Your whatever the keywords you're writing, whatever you're writing in the on your browser on the Google, it's just taken as a key, and related to the key, what are the values are available, uh, uh, what are the values having Google, it show you on the pages, right sir? So this is all the based on the key value format, as well the MapReduce works on the key value. Okay, now we'll see how it works in the key value, what are the key and what are the value we have in this coding. Before checking this part, well, there's a one problem called the record reader. Although we have the data into the string type, right? This data in string type, this data will be converted into key value format because your MapReduce work on the key value. So there's a term what the questions comes over time. What are the responsible factors which convert, which makes the string data into the key value? So record reader. Record reader is the term responsible factor which convert your data type into the key value. Alright. You can define the record reader. It's just like it. It's just a resource which convert. It takes the data from source, means your input, and convert into the key value form. Key value pairs you can say. Right. The factor is called record reader. So in the coming session we'll discuss more about record reader. It's just introduction about the record reader and their functionality, what it job perform. Key value is nothing. So fine sir. Is that clear? Now we'll see here in the splitting part what happened first. The job, the data has been split into line by line. Now we can see here K1 V1. Can anyone respond to what exactly key and what is value here in this data and status line? Can anyone help me? Make me understand what exactly key here and what is the value? Yeah. Yes. Any idea guys? No. Welcome back all please. So I think these are key available. Fine and Satish. Welcome back now. Right. So this is what what's in the answer. Dear beer river is value. Fine, Jeff. Great. And what is key here, Jeff? K is 1. Okay. Actually, I can. Thanks for your response, Jeff. On one attendee has response. Wait, one more. Equals are key and content is 1. Okay. At least we have to channel. Great. Now, guys. So, what exactly key and the value is all about? Your key is nothing. This all the data has been splitted into line by line. I asked you what record reader. Record reader is functionality to convert this data into the key value pairs. As well, it records this all the information into memory. Right, sir? Whatever the split has been done, they're putting this all the record into memory. Fine. Right. So if any data has been stored into the memory, there must be allocated memory, right? And this memory is being referred by any address, right? And this address is nothing, it's an hexadecimal value. So the memory which has been allocated to store this data having an address, and this address is being referred by hexadecimal value, right? Hexadecimal. So K1 is nothing here, hexadecimal. Fine, yes? If K1 is your hexadecimal value, is here every data for this line there's a one key and value. K is nothing. Every line is having a unique memory allocated with hexadecimal. So K1 is the unique memory address for this line, and the value is nothing, the content of the line, right sir? The content of this line, beer river, is the value. Same for this, the hexadecimal value, the unique one, and the value is nothing, the car river. Is that fun, guys? Things are clear. The K1 V1. So K1 V1, K1 is nothing, the hexadecimal value which is unique, and the value is nothing. The value is the content of this line, right? So key is the hexadecimal and the value is what? Content of the lines. Fine. Now we'll see here what is K2 and the V2. K2 and the V2. If we find that the value, right, K1 V1, K2 V2. Why the value get changed? K2 V2 and the K3 means that value of K and the V keep changing, right? So what is your K? K, of course it will be changed, right? We'll get back to you on both. So what exactly K and the V here? Okay, K is what? Your deer, and the value is what? 1. You can see the value of K and V get changed. K is nothing in your deer, and the value V is nothing your 1 value. Is that clear, guys? So key, this all comes under the key. Your deer, beer, river, car, is this all comes under the key, and the value is nothing which is being assigned. Fine. Now, right after this, uh, some voice problem. Okay, let me check. Everything is fine. Uh, guys, can I get a quick response? Can you hear me loud and clear? Yeah, Jay, is that fine? Anubhav? Okay, fine, guys. Yeah, Kanaya, Gupta, Kumar, Vincent. Fine. Just try to check your mic, your headphone, Vincent. That's problem. Yeah, Rahul. Is that fine? Okay. Okay. Thanks. Thanks, Acharya. Thanks, Stanley. Thanks. Thank you, always. Fine. Okay. Okay, sir. So this is what your K2 list of V2, your K2 and the list of V2. I'll let you know what exactly the list of V2 is coming. Now you see here the K3 V3s get changed. K3 is nothing. Your all the beer, car and the values get changed. Previously your beer was having the value 1, so now it's 2. So all the value gets changed. That is why we are putting the K3 and the V3. It's keep changing with the different stages, right? So that is why we are putting here. We keep changing the value of k and the v. Fine, guys. Now we discussed already what is suppling. Suppling is the stage where the node communicate to each other, right? Right. So this is what all the part comes under the mapper. This is all the three part that comes under the mapper code, mapper class. This all parts come from the reducer class, right? User. Fine. Now we'll see when we will write the code and all. Okay, let me come back to my chat window. Some question. Uh, Another question, what I remember here, no caching of data. So which memory address is this? Hey Anubhav, this is the mapred set XML dot local directory. This all the jobs and your intermediate regarding the the memory part. Anubhav, in the coming slides, will discuss. That is the directory name is mapred local directory, right? Mapred site dot local directory in which this all the job is being performed, where the intermediate value is being kept. Fine, Anubhav? Okay, we'll discuss. Any questions, please? Till now, things are clear. Yep. Yes, Jay. Any question? Anubhav, Gupta, Rahul, Satish, Vincent, Charya, Shalini. Things are clear. Thanks, Jay. Thanks. Yeah. Can I get a quick response, please? Okay. Thank you. Thanks, Jay. Thanks, Anubhav. Thanks, Kunaya. Thanks, Shalini. Thanks, Acharya. Hey, Vincent. Any question? Okay. Thank you. Rahul, can I get a quick response? Satish. Okay. Thanks, Rahul. Fine. Yes. Thanks, sir. Thanks for just keep me giving this heartbeat on the chat window. So I come to know you people are there and things are clear. It's very very important for me to make myself understand that things are clear for you people. So on the way to writing this all the things on the chat window. Thanks for giving me your acknowledgement, your confirmation of the chat window. Now we'll move to slide, previous slide. So this is what a simple case that we have discussed, right? This is not the universal flow, right? This is just a one case which we discuss about the flow and the algorithm for the word count. Actually, you can see the overall MapReduce word count process. So don't take it as the universal flow of MapReduce. It's just a one case of the word count. Now just take a universal code for MR flow. You can see here. Now wait, one thing I just forgot to. Hey guys, you can see here the mapper output becomes the reducer input, right? Here the mapper output is becomes the reducer input, and the reducer output, it's called the final output, right? Fine guys, mapper output become the reducer input, and the mapper output become the final output. So you might be noticed, just take a look. You might be noticed when the map and reduce start together, that's why the map started first, right? When the map job is 100%, means the mapper output is given to the reducer as a input. So that is why mapper is done, then reducer will start, right? And once the reduce job will be done, both the map and reduce will be finished 100, the job has been completed, right? And the final output is given by the reducer. So you can see the output when it comes in the part R. Remember there were 3 files inside the directory: success, the logs, and the part R. When you create the logical directory, the output will come in this file, part R 0000. So R is nothing representing a reducer output. Fine guys, clear? This is what R output. R nothing is your reducer output, because the final output is being given by the reducer. Fine guys, your mapper output as well, it is called the intermediate value. Just write down if you want to write. It's very very important. The mapper output is as well called the intermediate value, and this intermediate value is being stored on the MapReduce.xml MapReduce dot local directory. So in the day 2 we have discussed the directory of MapReduce all about. So now ask question about the memory where it's been kept. The mapper output is being placed on the MapReduce.xml. So in the coming session we'll discuss about some more discussion on the memory, where the mapper output is stored, where the your final output, and where this all the data is being stored, and when the flow happens, what is all the resource and spreads. We talk about the input spread, number of things theoretically we have discussed. We'll discuss in the next session, right? Now you can see this is the universal flow of memory. This is your data. This is the node. We have a three machine. You can say node 1, node 2, node 3. We have 3 machine. On this 3 machine, the input file is given to the mapper, right? See, the mapper output is given to the mapper, right? This is the mapper. This is the common flow. The input file is given to the mapper. Mapper processes the data. This data is called the intermediate data, which is called the mapper output. Then you can see every node, the mapper output is given, and then it gets shuffled. Shuffled means where the node communicate to each other, right sir? This is the node where they communicate to each other. Clear guys? And go back. You can see where the node communicate to each other. Shuffling is the stage. Right? Now, after the job is being done, your reduce job will start. Reducer will start processing to get the final output. Fine. So here the reducer will start to get the final output. Right? On the node, the mapper output given to the reducer, and the reducer get the input, and the final output is being given by the reducer. So this is all the final output which is coming on different data node, right? This all the output is being implemented on the single data node, and where it is being placed. Final output comes in K3. Clear guys? Any questions? Diagram, okay, chair, diagram showing 3 reducer. Yes, it is a 3 reducer. Not 3 reducer, every node is having its own mapper and reducer. Remember, so the very first day we discussed about, right? Every mapper is having its own reducer. Yeah, so as number of nodes, as number of maps, and as number of reducers. Every map is having its corresponding reducer. So which one you're talking? If you're running on Studio, yes, only one reducer because you are having a single machine. Punch it. You work on the multiple cluster, means fully distributed mode, means three cluster. So come from the fully distributed mode. So can we have one example writing MapReduce and running on? Yes, fine. Yeah, no, sure. We'll move to that part. Okay, right. Now this is what your mapper. Now we talk about the mapper and the reducer classes. Just take a look, and then we'll move to the coding part. It reads data from input data split as per the input format. This is what your K1 V1 K2 V2, right? This is what the K1 V1 is the input file which is given to the mapper, and K2 V2 is the output given by the mapper. Because K1 V1 is the input and the K2 V2 is the output. Answer here of input and output. In the mapper API, we talk about your long writable text and writable. So long writable text is nothing with K1 V1 and K2 V2 is nothing with text and writable. Exactly, Jack. Right? So long writable text is writable. Fine guys? K1 V1 is nothing, it's a mapper input and the mapper output, and these are the format. By default format we have the long writable text, which is K1 V1 representing, and text and writable is your K2 V2. Right? Key value, long writable key value pair input mapper, key value, and the text key value output mapper. Okay. Now over at map method, in the map method we have long writable key, text value, context, source, long writable. This is the method which we use to write the code to get the output from the mapper. Right? We'll see the code as well. Same we have the reducer. The key through list is your uh, there's some problem, there's some mistake is it should be K2 list of V2 should be given there, and should be K3 V2. There's some misprinted actually. It should be K2 list of V2. We can see the mapper output given by the shuffling, that is what K2 list of V2, and the final output is given in the K3 V2. Right? So it's just misprinted. Yes, you can give it when you give the K3 not an issue, but as I've seen in my corresponding this part, so that is what's showing in the K3. Okay. Now text. The mapper output, you just understand the mapper output is the reducer input. So remember that whatever the mapper output you have in which format, it should remain the same. The mapper output is coming into text and writable. Your reducer input as well come to the text and writable. You can see here the mapper input, sorry, reducer input as well coming into the input is the text and writable. What is the mapper output? Coming text and writable. It should always same, else if any mismatch we will get the mismatch error, right? And the mapper output, what is the K3 list of K3 V3? That is your text and write, right? Now we'll move to this part and to code. see we have a couple number of assignments, so we'll share this all the assignments to you people. So just now we'll work on the word count. As of now, we have run a program by using the predefined jar file. Now we'll write our own jar file to get the final output of word count. We can see this is the code. Now, we'll read it. Now you can see there are a couple number of files we have to import. You want to run the MapReduce count, and these all the files should be available in your code. And these all the predefined class. These all the classes being used in our coding. We'll see one by one, right? Now, have you used inner class? Okay, so I've used inner class. Now just take a look what exactly the flow, right? Now, public class word count. Inner class, my main class is word count. We talk about in the MapReduce, we write three classes. Mapper class. This is your mapper class. Those who are from Java background try to understand the technically. Those who are not from Java background don't focus much on. It's my recommendation. Just try to understand the flow and the functionality, how the job is being done, right? So it's a little tough for non-Java background to understand technically. So my request to just focus on the flow, how exactly the job has been done, and the responsible factors, right? Now this is what your inner class. So this is what we discussed. We are writing three codes: mapper class, reducer class. This is my reducer class, class reduce, right? Reducer class and the driver class. The driver class is nothing where this all the for mapper and the reducer class has been called. Means your main method. Hope you understand from Java base, where we are declaring the main method public static void main, that is called the driver class, right? So I'm putting this all the code into a single class, which we have used the inner class mechanism, right? Right. The public class word count, public static class map extend. Now we go on that. Now this is my class map which extend the properties of MapReduce. MapReduce is nothing, it's a predefined class. You can see this MapReduce class has been imported, right? And we use an interface implements and mapper with an interface which is having the default parameter long writable text, which is nothing but key of k1 pair of k1 key and the value, and this is what your pair of key value, which is the output. This is your mapper input as well. This is the output, right? Now I overwrite one method. This method is being override. That is your class which we used, override method, in which we declare this long writable, pass the parameter, right? Long writable in text, which is your part, and we collect the output text in writable. For that, we write a class output collector in which the mapper of the output of the mapper is being collected. So output collector, you can see here is mentioned. Text in writable is your output which is being collected inside the, right? Output collector declare its reference output. And this reporter is something old tradition which we don't use now in our code. This is the API which I'm writing the old API MapRed, and the market is they're currently using the new API MapReduce. So once when we'll read the code, and when the next session we'll discuss about what exactly the MapRed and the MapReduce API. And just now you understand the MapRed is the old API and the MapReduce is the new API. Fine, sir. Now we just take a look what the job. So the job we have seen in our slide. Now we'll see how exactly the job has been performed. This is the input file, then it is the mapper. This complete job has been how converted technically and we perform it. Now we'll see your input file is nothing. Your input file is your string data type, right? So I have stored my input file inside in the variable, and the data type of this file is variable is string, right? After taking this data, I have to split, right? I have to split this file into line by line. So how we split this? There's a term called string tokenizer. I hope you understand. Those who are from the Java background, they must be familiar with the string tokenizer. Job, such kind of job is being performed by string tokenizer. Like if you want to convert, if you want to split the paragraph or page line which you have, and you want to convert, split the data into line by line, there's a predefined file we use, string tokenizer. Alright, so string tokenizer, we declare a string tokenizer. Inside this string tokenizer, we pass our file. This file, the input file which we have stored into the line. This is a logical name, just a logical name, which is a variable line. I just put it. Okay. Now just take a look. Just show you how exactly the job is done. Suppose I have written, and that time you might remember this is my pen. This is my pen. Right? Suppose this is my input file. This is my pencil. Right? This is my pen. This is my pencil. I have written this code. Now, at this when and this data has been stored in a variable assigned, we have a line. Now when we assign this part, it will split this data, this file into line by line. Alright? Now this file will be split into line. Fine? Line by line. Now after this job, I want to split even this line into word by word. Every line should be split into word by word. Even these jobs can be performed with string tokenizer. I have to just specify the delimiter. For an example, this line is just like a comma, right? Delimiter is nothing. You have to declare on which fashion, on which part, on which base you want to split your line. So, for example, I specify the delimiter comma. So it will split the data, this line, whenever it will find the comma. For example, I just put two comma in my data, right? So how it will split the data? This, it find comma, it will split it, then it will write is, right? After reading is, there is no comma, it will get into my. Then it will split again, because again comma found, now it will split. Now I hope you understand. This is my file. Fine. The job is being done. Right? Here we have not specified any delimiter. Why? In case if we don't specify any delimiter, this was my data, right? So my data, if we don't specify any delimiter, then by default it takes the delimiter space. Understand, guys? So hope now you understand why I have not specified delimiter, because I want to split my data whenever it gets the space. This space is split the data. Again after space it will split the data. My again it will find the space, it will split the data. So now my job has been split into whenever it gets the space. Same for this one, right? This is my pencil. Clear, guys? Now how exactly it will work? This is my pen, this is my pencil. Now I have done almost my job. You can see the map for the final output, but map for output not come in this way. I have to assign a value for every split, right sir? 1. We have done almost job. I have splitted every data into word by word, but I have to give a value. I have to assign a value for every data. Now we'll go further. So we'll see from here. Now this all the data which has been stored, now this all the job has been stored inside the tokenizer. All the split, all the words have been stored in the tokenizer, inside the string tokenizer, right? Tokenizer is a reference. So this all the data has been stored inside the tokenizer. Now let's just take a data to KELI. It will just example tokenizer that will take this data. Yes, this data is my all the words will get into this and stored inside the tokenizer. Right. Now next one is THIS is this is my pencil. Okay. This is a pen, this is my pencil. It will come like in this way. Splitting and splitting, and this all the data will get stored inside a tokenizer. Now I have to assign every value 1. Now I will put a loop, kind of loop. Tokenizer has more tokens. What does it mean? It will check whether tokenizer has more tokens. Token are, these are the tokens. Every word has been treated as a token. It will start from very first. It will say tokenizer has more tokens. It will say yes. Tokenizer has tokens. Now I want to display this token. If I want to print this token, I used next token. What the tokenizer having the token? If you want to display the token, I use the function next token, which is being now stored inside the value. Right? I will take another. Now this all the jobs is being now taken inside the value. VALUE value. Fine. Now inside this value, this token will be stored. Now what is your value? This. Right? Tokenizer that has been stored inside the value. Now output dot collector. Remember we talk about the output is nothing, it's a reference of the output collector. Now this collector has called is being used. It just reference, this is the uh, Java concept. Whenever you want to call a non-static method in output, it has been called by the reference. So output collector having a method called the collect, in which all the output is being stored. This is the output value check. Out call, the output is the collector. Okay, output dot collect. Now, what is the output? Text in writable view. Text is what? Your value. Value, what it does it store? This, right? So it will print this. How the output will come? Panel. So output will come like this, right? And the new int writable, it will assign your int writable value. We are assigning here what we are writing. It will take it. Now what next? Again the loop will move. Tokenizer has more tokens. It will move. Yes, we have done this. Is now it has been again put into the value. Now the data will get. It will put this data into the value. Set the value again. Is one. Now it will keep going on. This is, I hope you understand, this is my will get 10. Next we have again, this is my, this will get 1. This is 1. Nine, 1. Pencil. Fine guys? Understand the value bar. Now this is the output which we have seen in the mapper. This is what called the mapper output, and this is what your list of K to V2, right? This is nothing. K2 fine guys, hope you understand. This is all the list of V, and this is a list of key, and this is all the list of value. Okay. Now now what next? Now there's a some shuffling, right? This is the mapper output guys. Mapper output is as well called the intermediate value. Now what we have? Shuffling. Shuffling is what? Where the node communicate to each other, where they are making the group of the words of their different categories. Now we'll see. We'll see now this all the node communicate to each other. Now we'll see here. I will make a group. We have a group of data. This one. And more this we have. Right? Is have 1, all will get accumulated 1, right? This your mice as well come twice. My is as well comes twice. Right? This is my pen coming once, pencil coming once. Fine guys, this is what the actually shuffling. But your mapper, it is something to this. It is not like this. The mapper output, we talk about the mapper output is given to the reducer, but exactly not this is the output. The output is not given to the reducer in this format, this one. The output given after modifying the mapper output. The mapper output is being modified and which is being passed by the shuffle. So when the mapper gives this output, this has been shuffled, and actually the mapper output, the shuffle gives the output to the reducer in this format. Just take a look. They make this common sequence of key into unique key. There's a sequence of key what? This is the sequence. See, this is all the sequence. This is coming to it. Now make this sequence of the key into a unique key. So this is nothing. Here it comes. Here it was K2 and here it was V2. Right? Now here it what did? Make the K2 remains K2, but it makes the list of V2. List of V2. What does it mean list of V2? Whatever this value is having, it will put inside this. 1, 2 value we have now. That is what we are listing of value. Make this series of key this in a as a unit. So for is 1, how many value we have? 1. So for my for pencil, we have only one value, so it will list the. Now I hope you understand now why K2 and list of V2. Can I get a quick response, guys? Thank you all. Okay, thanks. Right. Now this is what my K2 and the list of V2. Clear? Now what I will do, this is what exactly the output is given to the reducer. This value K2 and the list of value. You can see this is what the mapper output intermediate value. Actually the output is given and get modified by the shuffler, and this is the K2 list of V2. The mapper, the reducer output, the mapper output, the intermediate value is given to the shuffler. Shuffling modify the data, and this is the what the value is given to the reducer. You can see this data is given to the reducer, so it will very easy for the reducer to understand. Now just take a job of reducer. How reducer work? You can see here. Okay. Now just take a look here. Now the output is given to the reducer. We talk about the reducer is what text is writable, and we already discussed the mapper of input and the mapper is the reducer input and the reducer K3, K2 list of V2, K3 list of V2, right? We have discussed already. Now how it takes the data, how it converts it. Now what it will done, I take a sum, a variable sum which is the 0. Now first it will be given, this all the data will be given to a different data node, right? So all the data will be given to different data node, and just take a look, this data is given to data node 1, right? How reducible perform the job. While it will write value has next, it will take this key, alright? It will take this key and it will ask how it takes the key. You can see here, this is what the text key and the iterator means it will keep it just like a loop while we are using the iterator for the iterables, right? So output collector, again the output will be collected into, right? So it will take the output collection like this, text iterable, sorry, the value, it will take this key, read first this, it will make this is this, right? And it will take the value sum 0, that will ask as this value has next, means this key having the value, it will read the first value yes, if it yes, it will get into that and it will increment sum by 1. Now your value of sum become 1, right? Again it will move to the, it will again ask value has next, it will read yes, we have value. Now again sum will be incremented by 1, it will ask the value has next, it will find no, we don't have value. Now finally it will come out from the loop. Now the final output will be given to this final output, again it call the reference from here, output collector iterable collector, text iterable is the output format, text is what your key is what your this, and the iterable what sum. So sum final output is 2, right? So now it will write, the value will come like this. Now we have is, same for is, it will again put the loop is, then the 2 my will keep putting the value my 2, same for this, then 1, then 0. That's it. This is the final output which will be given by the reducer. Is that clear, guys? Now this is what your main method, your public driver class, from where the output is being delivered. Right? Main method is nothing. This is all the classes. In the next session we'll discuss. We're short of time, so we'll wrap up by today for this part. In the next session we'll discuss about on the session now. And come back. I'm back onto the chat window. Now, question, guys. Is that clear? Yes, everyone is clear. Is that much expressive? Is that fine? Okay. No question. Thank you. Thanks. It's clear. Okay. Yavansan, Rahul, Gupta, Shalini, everyone has questions. So, towards some question, I guess. Anubhav, in the next session, we'll make the jar file of this code and we'll make this. Fine, Anubhav? Okay. It will be late. It's already 10:20. Hey, Ashish. A little late. Anyways, welcome. So we have almost done. for today's session, guys. I hope things are clear. Yeah. Thanks. Madhav. Okay. Basically, what type of procedure, processing or filtration we want to do with data? We have write the logic in any of the language. Yes, yes, yeah, correct. This is what the beauty of Hadoop. You can implement any language with this, and you can start. The same job we can perform by Pig. The same job can be performed by Hive, .NET, whatever. In my training program, I'm using two different programming models, that is Pig and the Hive, which is quite easy to understand and write the code. You'll find that number of jobs you have written 20 to 30 lines of code to perform this job in the Pig and the Hive. Just 2 to 4 keywords is being used to perform this job, right? So this is all the art and the beauty of Hadoop, how to make it, how to write it by different using programming models. So in the further session, we'll have a discussion for the Pig and the Hive, and we execute the same job for this we have done here. Okay, Gupta, clear? Okay. Thanks always. Hope for what I think with right SQL command will be easy. No, Okanaya, we are not working with SQL. SQL does not deal with the complex machine, right? We are not working with that, but yes, SQL and the pig. Your SQL is quite similar to SQL based, right? We'll have a more discussion on the when we'll introduce this part. We'll have a more discussion which is quite interesting. Hive, what are we will discuss about the Twitter data, how to process this Twitter data, or we have the Facebook, LinkedIn, Google, how Google's search engine, how HBase is capturing this all the metrics. We have couple number of things we have to do. It's just introduction and it's just programming the basic of MapReduce. The interesting part is the Hive with the pig we have. It's yet to come. Fine. Okay. Thank you. Thank you all.